random variable. Okay, so we talk about first in here what we call a standard normal distribution. And when we say it's a standard normal distribution, that only means that, what's mu again? Anyone who can tell us what mu is? That's the mean, population mean, okay? The x bar, by the way, is sample mean, but the mu, those Greek letters are the population details, right? And the sigma is the population standard deviation as well, okay? So again, if it's standard normal curve, then that means the population mean and standard deviation are both 0 and 1. Now, where's the z-score? The z-score is like how far, still the same. It's a random number or random variable according to the standard normal curve of like how far it is still from the mean as well, okay? And as you may notice in here, if that is the z-score, typically for our table of values, the area under the curve to the left of that z value, that means the probability of your random variable x less than or equal to z is that area in there. So for example, if it says in here that this is at 20 or 0.2, okay? If px less than or equal to z turn out to be 0.2, then that means this is the what? This is the 20th percentile. Okay, what do you mean by 20th percentile? That only means that if there are 100 people in this population, 20 of them will be from that z-score to some other scores below that value, right? That's what we mean by 20th percentile, okay? Now, in terms of formula and relationship between the population mean, the population standard deviation, the z-score, and the random variable, here it is, that the z-score is equal to the random variable x minus the population mean all over the population standard deviation. In some cases, if you need that value of x and you are given already that value of z, typically z will be on a z table of values, then we can use this formula, okay? Multiplying both sides by the standard deviation, then that means sigma z will be multiplied together, and putting this away to solve for x, then you add both sides by the population mean, then that means x is equal to mu plus z times sigma, right? So in some cases, we would be able to use that one as well if we need to know what the random variable number is. Anyway, let us consider some in here to figure out how to compute for them, okay? So here it is. Example number 1, and see how we can work on this one, okay? Let's read this one first. Tiff, go ahead, please. Pediatrician.
A pediatrician obtains the height of her 3-year-old female patients. The heights are approximately normal distributed, with mean 38.72 inches and standard deviation 3.17 inches. Use the normal model to determine the proportion of the 3-year-old females that have a height less than 35 inches.
All right, so there we go. So as we may notice in here, it already says that this is what? That the heights are established to be normally distributed. Okay, and with that being said, the population mean is already given for us in this case, and with that being said, we can already consider getting the proportion of the 3-year-old females that have a height less than 35 inches. So with that, we can visualize how it looks like. Okay, so how does it look like? So again, we can use symmetric bell-shaped distribution simply because it says it's approximately normally distributed already, okay? Now in here, that will be our mean. And what is our mean in here? 38.72 inches. Okay. Also, it says that the standard deviation is how much? 31.7 inches, right? Thank you. So with that being said, so if we consider just one standard deviation above and below, then what would that be? Above, that would be what? 38.72 plus, what's the standard deviation again? 3.17, right? So plus 3.17 inches, what's that gonna be? Let's put it in here. 38.72 plus 3.17 inches. And we got what? 41.89. So in here, that'll be 41.89. Now on the other end, what will that be? So in this case, instead of adding, we're gonna subtract that one standard deviation. So that's minus 3.17. And let's see what's that gonna be, guys. 38.72 minus 3.17. Oops. What did you get on your end? 35.55, okay? And again, as we notice in our distribution, that is what? 68% of our data set, okay? Now, where is our X? Now, it says in here, our X has what? Females who have a height less than 35 inches. Where's your 35 inches? So we can assume in here that 35 inches is somewhere on this area, right? Okay, so somewhere below the 35.55. So let's assume that this is your 35 inches, and we are talking about what? Proportion of these people who are what? Female patients, 3-year-old female patients, less than 35 inches, okay? So the question now is, how much will that be? Now with that being said, let's use the z-score for such. So to use the z-score, what's our formula again for z in here? Z is equal to, what's our x? 35 inches, right? That's our random variable. So it's already given, 35 inches. Minus, what's our mu? What's our sample, population mean? 38.72. Very good, right? So that's 38.72. All over, what's our standard deviation? 3.70. Very good, okay? As you may notice, all of these are inches. In short, all of those units will cancel out, telling us that z is actually a unitless value. Okay, so because the inches above and the inches below will cancel out. Anyway, what's the value going to be? Let's see. What's that going to be? 35 minus, what's that? 38.72. Okay. Divided by, what's the standard deviation?
3.17.
Thank you. 3.70. 3.70. And, are we good? Right? Okay. Can you still follow, guys? Okay, we're still using this formula, right? Okay. And what did we get? On your end, negative 1 point. Okay, so let's guys. Oh, on your calculator, what did you get? Negative 1 point. Oh, calculators. 1, 7. Alright, okay. Oh, we have calculators, guys. Okay, okay. So make your calculators useful. Anyway, so as you may notice, it's negative simply because it's to the left of our mean. Okay, so if that's the mean, anything to the right is positive, and anything to the left of the mean is negative, right? So that's negative 1.72. That means what? It's below the what? The 1 standard deviation mark. Okay, or by the way, the negative 1 standard deviation mark. Anyway, what's that going to be? The probability now of what? The probability that your z is less than or equal to what? Negative 1.17. Okay. Now, we're going to use our calculator, not calculator yet, the table of values for z for such. So please hold on to your z distribution table like this one. So this is our z distribution table. And let's verify in here where it is. Okay, so let me just go ahead and erase this one first before we continue. Okay. Oh, it doesn't look like this one is working. Oh, there, it's working. So, Mr. Deal, how do we even use this one in here, right? So let me just erase this one. Okay. So where's the probability that your z is less than or equal to negative 1.17 for such, okay? So how do we use this one? Well, first of all, the title for this, it says that this is what? Call it blue, okay? This is the standard normal distribution, area to the what? Left of the z-score, to the left. So we are correct with our value that's to the left, okay? So where is that z-score first? Negative 1.17. So how do we look in here? So as you may notice, these z values are all positive, all right? We want to see the negative part. So what do? We go see the other part of the table that has the negative parts. Here it is, okay? And let's see, where is that? Negative 1. As you may notice also that z in here is correct or exact up to how many decimal places? 2 decimal places, okay? 2 decimal places. Negative 1.17, so where's that? Where's negative 1.1? Look in here where that negative 1.1 is. Okay? But it says negative 1.17, so you're gonna add what? 0.07. Okay, see how we're using our table, guys? So verify on your table. On the row, look at the first 2 digits, negative 1.1. So as we may notice in here, that's negative 1.1. And on the column, you look at the second decimal place, okay? The hundredths decimal place, negative 1.17. That's what it says in there. So let's see, the column and the row turn out to be what? Is it that one there?
That's what I got. Yeah.
Got it? Okay. So verify on your table. It says 0.12100. Okay, so here it is. 0.121. Okay. Verify negative 1.17. And that's 0.121. Now, what is the interpretation of that one, right? That's that 0.121. Let's go back in here and give some analysis regarding that. What does it mean? Where is that now?
Are you talking about on the chart?
This is what? This is the proportion of what? 3-year-old females with height, right? Okay, less than 35 inches. Good. Okay. So again, those are the proportion of 3-year-old females with height less than 35 inches. Okay. We can also say that what? It's 0.12 if we multiply that by 100%. Okay, verify in here. If I multiply this by 100%, then that'll be what? Approximately what? 12.1%, right? Get it? Okay, and what does it mean? Well, we can say that 35 inches in there, height is the what? If that is the 12th percentile rank. Okay, in short, there are 12% of these 3-year-old females with height less than 35 inches. Okay, guys, right, with that one, right? So again, we can assume it in terms of proportion. The proportion is 0.1 to 1, but in terms of percent, 12.1% of these 3-year-old females have heights less than 35
It's
inches.
X. Wait.
Hey, we good?
Oh, I guess you just wrote it like that.
Questions? Questions with what we did?
Yeah. Do you want me to ask?
Now,
It's just confusing.
definitely we can check it out on our normal distribution curve as well, right? So let's use this one using StatCrunch. So if you go to your StatCrunch, so here it is, and how to do this one, Mr. did with StatCrunch. So here it is. You're gonna go to Stat. You're gonna click on Calculators. Here we go. You're gonna go to Normal Distribution under Calculator. Get it? Okay. Let me just erase this one, guys, first. So once again, I went to Stats in my StatCrunch. I went to Calculator. Since this is normal distribution, I'm gonna click on the normal distribution. Okay. And then on the mean, I'm gonna put the mean. What's the mean again? A while ago?
38.72.
38.72. Thank you. And what's our standard deviation a while ago?
3.17.
3.17. Thank you.
Yeah, it's supposed to be X. You just write Z.
And our x, we said our x to be what? Less than 35 inches. So as you may notice in here, oh, okay, 35 inches. So as you may notice in here, if you click in here, you can click on the less than or equal sign. Okay, but in here it says less than, so I'm gonna click less than 35 and click on compute. Okay, and yes, you can verify in here that we got the answer right as well, right? It's just that a while ago, we used the z-score method for such, but in here, you can still use the normal calculator approach if you want to. Questions?
You plugged in those data numbers yourself?
No. This one is, forget about it, guys. I just clicked on one of those StatCrunch, so forget about this one. We're just focusing on this, okay?
Can you do this part one more time?
So, one more time, guys, right? So please follow, guys. Here it is. We're gonna click on Stats, okay? Under Stats, go to Calculator.
All right.
Under Calculator, so there are different types of calculator. We have the assumption that this is normal distribution right away already, right? It says it's approximately normal distributed. So we click on normal. And yes, you're gonna get this, okay? And then after that, what do we do? Well, there are two. You can do standard, you can do in between, right?
Yeah.
So you only do in between if there are two values for x. If it says in between this minimum and this maximum values. But if it's not, then you just click on the standard. Okay. Now, again in here, you put your mean, right? Again, what's our mean again? 38 point. Thank you. What's our standard deviation? 3.17. Now in here, you have the option. Is it more than? Is it less than? So, or is it at least? Is it at most? So you can verify it there, okay? As you may notice, there's also no equal sign. Because when you say equal sign, that's always automatic 0, okay? There's no exact value for such. So, in here, why? Because this is not discrete random variable. These are continuous data. And put in here 35. That's it. Click on compute. You can also have the graph associated with it, and which only means that what? Proportion is 0.1 to 1. This one is more exact, right? Okay. Values. And if you multiply it by 100%, you can also get the percentile rank as well. Questions? Get
So it's 35 is greater than equal to x because it's a discrete.
35 is greater than or equal to x. Yes, so because these are the random variable values that are less than 35, right? Because you said your random variable in here will be what? Heights that are what? For this female children, right? 3-year-old children. And you want these 3-year-old children to be what? How many of them are less than 35 inch, right? So that means it can be 35 inch, can be 30 inch, 32 inch, and so on in terms of their heights. Good? Right? Okay. Now, again, this is not sample, this is population. Okay? Okay, let us now go in here and verify how we can answer this one in here. Let's read it first. Sydney, go ahead please. Still the heights of these 3-year-old female patients. Okay, Go ahead.
For the pedestrian example one, on the probability that randomly select the 3-year-old girl.
No. I think it's the third problem. It's the third problem.
I'm sorry.
No problem.
The height of the pediatrician 3-year-old female patients are approximately normal distributed, which means 38.72 inches and standard deviation of 3.7 inches. Find the height of the 3-year-old female at the 20th percentile.
Okay, thank you. So in here, it's basically the reverse. Okay, so in short, if the height of a certain female is within the 20th percentile of all those 3-year-old female, what do you think is the height of this 3-year-old female, right? Again, she is on the 20th percentile. In short, there are what? 20% of those females have heights less than hers. Okay? So in short, this is our problem like this. So what will that be in terms of notation? Here it is. The P of like what? X less than or equal to Z, okay, is how much? 0.2. Well, approximately 0.2. Okay, so that is what it means. That means what? The probability that the random variable height is what? Less than Z, such that it will be what? 20%. Okay, there are 20% of people to the left of that one. Okay, in terms of drawing, all right, let's visualize. We expect our drawing to be like this, all right, our illustration. If that is our normal distribution, and if this is our z-score, okay, or our x value, then that means this area below it will be how much? 0.2. Okay, so 20% of heights below that x will be equal to what? 0.2. Now, first of all, we're gonna know first what is that z value. Okay, so here's our step. Step number 1 in here is such. Step number 1. Let me put it in here. Okay, so that's first of all, determine z of 0.2. In short, what z-score will give us an area to its left as how much? 0.2. Okay, so what do we expect our z value to be? Positive or negative if it's 0.2? It's basically negative, right? Because as you may notice on the table, if you look at the table in here, look at the table, guys, right? If it's negative, okay, look at the table. If it's negative, look at the P values. It's always less than what? 0.5, right? It's less than 0.5. Again, because this is to the left of the mean, then that means it's less than 1/2. Okay? However, if it's positive, what do you notice? It starts with 0.5 until 0.999. So these are what? Values more than half of the data set, right? Again, we're talking about left, right? Okay, get it? So, 0.2, where's that 0.2 again? So going back in here, 0.2, we know that is negative. And let's see where that one is, okay? You know what? Let me erase this one first and verify in here where that 0.2 is, okay?
So should I ask him if that's supposed to be left too?
There we go. You know what? This hand is better than this eraser, right? Well, some cases. Okay, there we go. Again, as you may notice, this is your x. Where's our x, by the way? This is our mu, right? And we know that this is what? 1/2, right? Because that's a central tendency, right? So that means any value of p less than 1/2 is negative, okay? Right? Any value of p more than 1/2, the z-score is positive. Right? Since this is 0.2, it's less than 1/2, so we expect it to be negative. So where's that 0.2? We will not see an exact value in here, but we would see something that's closest to it. Okay, so look at those values, the one that's closest to 0.2. So verify, verify, verify. Where is that? So I'm gonna go down more in here and verify in here. Which one is the closest to 0.2?
-2.5.
0.2. Oh, here. Which one in this among these two is the closest? 0.197, 0.198, or 0.200? I think this is the closest, right?
Yeah, I agree.
Okay, so there we go. So we're gonna use that. What's that? Negative 0.8, and what's this? Yeah, what is this? Let's see, verify.
Yeah, it is.
I'm gonna go down. Okay. Thank you. Point zero. Yeah, there we go. Very good, right? What did I get a while ago? 0.84. Is it negative 0.84? Negative 0.84. Let's verify again. Okay. Okay. And what is that? 0.2. Again, 0.2 in here. Let me erase this one. So we know that's 0.80, 0.04, and 0.2 is somewhere there, right? Okay, yeah. There we go, right? Yeah, that's correct. 0.84. Okay. Negative 0.84. Good. So that's our z-score, negative 0.84. So let's verify that one. Going back to the problem. So z at 0.2 is, how much is it again? Negative 0.84, right? Negative 0.84. Now, step number 2. Solve for x, okay? Or the random variable x. Again, the x in here is the height. And what's the formula for the x? Mu plus z sigma. Right, so let's use that one. The height is equal to what again? Mu plus z-score that we got, which is 0.2, times what? Sigma, which is our standard deviation. Okay, so let's use that formula now. Okay, so here it is. Let's use that formula for such. X, or the height at the 20th percentile rank, is equal to mu. What's your mu again? 38.72.
Yeah.
Times sigma. Yes, that's correct. Plus, what's your z? Negative 0.84. Again, so that's negative. Oops, negative 0.84. Times sigma, the standard deviation. And what's our standard deviation? 3.7. Okay. The 0.2 a while ago is the 20th percentile, right? 0.2. That means 20% of those heights are below this. Okay, let's use our calculator for this and verify how much that's gonna be. Verify, what's that again? 38.72 plus, okay, what's our z again? Negative, what's that again? 0.84. And the next one is 3.70. 3.70. Okay. And we verify, what is that height? 36 inches. Okay, so approximately 36 inches. Okay, so we can put in here approximately 36. You know, let's put in here 0.6 inch. Okay. And the last one definitely is to verify it either with a StatCrunch or our Desmos calculator. Okay, so let's verify using our Desmos calculator if we got the answer right. Okay, just really quick. Let me just erase this one. Okay. Okay, verify it in here. Okay, so how to verify it in here? Here it is. We can use StatCrunch, we can use Desmos as well, right? So this is the Desmos. I put in what? Normal dist. Okay, what's our mean again? 38.72. Thank you. Comma, what's our standard deviation? 3.17. That's it, correct. And I'm gonna click on CDF in here, and I'm gonna put the maximum value to be what? 36.06, right? So we are gonna see, okay, because 36.06. So that's the maximum height. And 20% of the individuals will be below it. And as you may notice, what did it say? 0.2, right? So that means what? 20% of these females have heights less than 36.06 inches, okay? And visualizing that one in here, here it is. Under the x-axis, I'm gonna put what? What's that? 38.7. So I'm gonna put in here the following: 30 to 40. Okay. My y-axis is always 0 to less than 1. So let's put in the point 0.01. Okay. Oops. 0.10 or 0.3. Okay. 0.30. Right. And as you may notice in here, that is the data set for such, okay? So the mean is in there, 38.72. And as you may notice in here, this shaded part is how much? 20%, right? So that means that 36 inches high is on the 20th percentile rank, which means that 20% of these population have heights less than 36.06 inches. Okay, so yes, you can verify it either by StatCrunch or Desk. Okay. Thank you all so much, guys, and please continue working on those Z tables. Maybe we can answer maybe 1 or 2 more questions for Z score before going to 7.3, assessing normal.